Evaluate logarithms. This is how we are getting started with evaluate logarithms. So that may be the first question for most of my students. Well, I recommend you when you're starting with log, you can also use your calculator to check your answer for this particular question. Calculators do have log and their base is 10 as shown here. Normally, whenever the base is 10, we don't write the base, right? It is understood as 10. Now, write down your answers, check them with your calculator this time, okay? So that will give you kind of a comfort level dealing with log. So we'll slowly move into complicated questions. This is my first question on evaluate logarithms. So when we say log of 10, so imagine this to be base of 10 and we don't know what this is. Then how do we do it? We write like this. Log of 10, let it be x, right? We don't know what this is, right? So let it be x. Then we can write this in exponential form. So if I write this in exponential form, then I can write this as 10 is equals to, this base is 10, right? 10 to the power of x. Now I know 10 to the power of, this is 10 to the power of 1 and this is 10 to the power of x. Comparing the exponents, I can say, well, x is equals to 1. Do you see that? So that is how I get my answer. So remember one thing, log, if they have the same base and the number, then we always get 1 as the answer. The reason is very simple. The reason is we know logarithms are inverse of exponential functions, correct? So if you have anything to the power of 1, right? So if I have bases, let's say b to the power of 1, right? So b to the power of 1 will be what? So base, same, will be b. Do you see that? B to the power of 1 will be b. Do you see that? So that is the fundamental. And when you do reverse of this, that means, so base is same as this. Do you see? This is the base, right? Then you get answer as 1. Do you understand? That is how we get the same answer, right? So if I have log to the base 2 of 2, my answer will be 1, right? Since 2 to the power of 1 is equals to 2. Do you understand? That is the concept. That is the concept. So when I say b to the power of 1 equals to b, this is what I mean, correct? Now the second one. The second one for us is log 1. So we say, well, we can write this as log 1 equals to x. We don't know what this is, correct? But we know this is base 10. So this implies that 1 is equals to 10 to the power of x, right? So that is the exponential form of logarithms, right, by definition. Now 1 is equals to 10 to the power of x. What should be x? So that 10 to the power of that number is 1. The only number which satisfies this is 0. Do you see? Anything to the power of 0 is 1. So let me write any base here to the power of 0. Anything to the power of 0 is 1. That is the answer, correct? I hope you are understanding. From the very basic concepts, we're trying to understand all these things, right? They're simple, but they're fundamental and very important to understand. Next one is log 0.001. Now this I can write as 10 to the power of minus 3, correct? 10 to the power of minus 3 is 0.001. Now I want to figure out what is this equal to. Let it be equal to x, okay? In that case, it implies that 10 to the power of minus 3 is equals to 10 to the power of x, correct? Now we can compare the exponents, just as we did in the previous two questions, correct? And so we get x is equals to minus 3. Do you see? You get your answer. So that is so simple as that. So that is how we get the values. So the idea here is we have to write this number as exponent of the base. Then the exponent is the answer. Do you understand? So we'll use that principle here. So we have minus log and 100 could be written as 10 squared. Is it okay? That seems to be correct. Now let it be equal to x. So that implies what? That implies that 10 to the power of 2 is equals to 10 to the power of x, correct? So actually in this case what happens, this is minus, right? Since we will follow this method, so keep the minus with minus 10. So this is kind of a different property of log. When it is minus, then you can write this as minus x here, right? So let's make it plus. Let me go one more step here. So I'll write log 10 to the power of 2 equals to minus x. Let me write like this for the time being, okay? So that really means that we'll go a step ahead and now we'll write it in exponential form. So we see 10 to the power of 2 is equals to 10 to the power of minus x. Do you see that? Minus x. So we have minus x equals to 2. Do you see that? So from here we get, let me just use more space here. So we have minus x equals to 2, and that implies that x equals to minus 2. Do you understand? So that is how we get our answer. X is equals to minus 2, right? Then we will get this answer. Okay. Now next one is log of minus 10. Well, domain of a log function, let me just sketch now the log function itself, okay? So when we have a log function, then it is kind of like this. Now this is a vertical asymptote, and it is, exponential functions are like this, that. Exponential functions like this. And log is inverse of exponential functions. So when you flip it on y equals to x line, horizontal asymptote becomes a vertical asymptote. Do you see that? So for exponential function, domain has no restriction, but range has. But when you do inverse, range becomes the domain, and therefore domain of log function has a restriction that it has to be more than 0, correct? So that is why this thing has no solution at all. So let me write down no solution here, because the domain is wrong, right? It is not defined in this domain, right? So it has no solution. How about log to the power of how about this? Log 1 over 100. Now log 1 over 100 can be written as log 10 to the power of minus 2, correct? Now, well, let it be equal to x, right? So we'll follow the same policy and say, well, 10 to the power of x equals to 10 to the power of minus 2, right? And if we compare the exponents, then we get our result, and that is that x is equals to minus 2. And this is how we are going to solve or evaluate logarithms, right? So I'll have a couple of simple questions so that you understand and get the concept, and then we'll move on to more complicated ones. I hope you appreciate it. Thank you.